Hey, 5th grade mathematicians, we're going to take a look at entry task day 111. Number 1, enter the product 2 3/10 times 6 75 hundredths. So what I'm going to do here is I'm going to put 6 75 hundredths on top, and I'm going to put 2 3/10 on the bottom. Now, unlike addition and subtraction, where you line up place values, you don't need to do that when we're multiplying, but we do line up digits, not place values. So this is in hundredths, 6 75 hundredths, but I'm going to move my decimal point to the end, and and then this is 3/10. I'm going to move that out, and we'll put that in later. But we need to remember that this is hundredths, and this is tenths. Okay, so we're going to go ahead and multiply using the standard algorithm. So we multiply 3 times 675. So as we do this, and we want to make sure that we add our carries. Okay, and we move to the next partial product. Put a 0 in ones place. 2 times 5 is 10. Carry our 1 again. 2 times 7 plus 1 is 15. We will carry our 1 to the next place value. 2 times 6 is 12, plus 1 is 13. Now we're going to add our partial products. And at this point is when we're going to bring our place values back in. So hundredths times tenths are thousandths. And when we have thousandths, we're going to have 3 decimal places. So I'm just going to check this out. 1, 2, 3. So our final product is going to be 15 and 525 thousandths. Now, what I want to do, I'm going to write the answer in here, and then we're just going to, well, let's just check this out first. So if I was to do an estimate, 6 75 hundredths is close to 7, and 2 3/10 is close to 2. So I would be looking for an answer that's around 14, and that is what we have. We have 15 and 525 thousandths. And there you have it. Let's go to problem number 2. And in this problem, we have a rounding problem. It tells us to round 925 and 197 thousandths to the nearest hundredth. So I want to zoom in on this a little bit, and this is how I like to solve this. So first of all, to the nearest hundredth, I'm going to circle the place value, the digit of the place value that I'm going to round to, and then I just put a little arrow over the digit to its right. And we know that we use the rule 5 or more, let it soar. 4 or less, let it rest. So in this case, we have 7 thousandths, and that means that it is closer to 1/10 Okay, 1 more tenth. So what's 1 more tenth than 9/10? Well, we would have 10/10, but we can't put 2 digits in one column, so we would then carry it to, not tenths, but hundredths. We would carry it to the tenths place. So we would round this to 925 and 20 hundredths. Okay, so in this one we don't just raise the hundredths one, but we have to go into the and carry that over into the tenths. So our rounded number is 925 and 20 hundredths. Now the reason we do put the 0 in the hundredths place, we know that 925 and 2/10 is the same as 925 and 20 hundredths, but we're specifically instructed to round to the nearest hundredth. So we want to leave that 0 in the hundredths place. Okay, let's move on to problem number 3. 5 students in a class recorded the distances they ran in miles yesterday. Select the line plot that correctly displays this data. Well, the first thing that I want to do here is I want to look at the data, and we want to do a little simplifying here. Okay, so right away I see that 15/10 can be written as 1 5/10, or I'm just going to write 1 1/2. Now we can make an equivalent fraction pretty easily with a half later on if we have to. 6/3 is rounded to 2. 2 0/12 is rounded to 2. 10/5 is rounded to 2. And 1 2/12 can be simplified to 1 1/6 because 2 goes into both 2 and 12. So let's go ahead and look at our line plots. And what I notice right away is I'm looking for a line plot that has 3 2's. And we see 3 of those are possibilities: A, B, and C. So I'm going to cross out D because it cannot be D. Okay. From there, I want to see which of these also has 1 1/2 and 1 1/6. Well, A has a 0, and there is no 0 as a data item. So it's down between B and C. So let's take a look at B. I'm going to zoom in again. So this is 1 1/6 here. This is 2 6, 3 6, 4 6. That's 1 4/6. Well, that's not one of our data points. 1 1/6 is, but not 1 4/6. So this one, C, it has to be C. That's the only one, but we just want to confirm this is 1 1/6. This is 2 6, and this is 1 3/6, which is equivalent to 1 1/2. So C is the correct line plot. Now we're told to enter the total distance in miles the students ran. Well, the first thing I can easily see is 2 plus 2 plus 2 is 6. I can easily calculate that. So I have 6 plus 1 1/2 and 1 1/6. Well, 6 plus 1 plus 1 is 8, and I'm left with a half and a sixth, and I can easily convert halves into 6, So that'd be 8 and 3/6 plus 1/6, which is 8 and 4/6, which is 8 and 2/3. Okay, so we'll go record our answer. They ran 8 and 2/3 miles total. And there we have it. Okay, now problem number 4. This says patterns A and B are generated using these rules. Pattern A, start with 4 and add 4. Pattern B, start with 2 and add 4. So let's do pattern A. Well, let's read the next part first. It says, which statement best describes the relationship between the corresponding terms of pattern A and pattern B? So what we want to do is we're going to do the rule first. So we're going to, pattern A, we'll start with 4. And what's 4 plus 4 is 8. And we're going to continue adding 4. 12. 12 plus 4 is 16. And 16 plus 4 is 20. I'm just going to do the first 5 terms. So for pattern B, we start with 2 and add 4. 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. And 14 plus 4 is 18. So now we have to see what describes the corresponding patterns. And when we talk about corresponding patterns, 4 and 2 are corresponding. So if we wrote that as an ordered pair, pattern A would go first, and it'd be 4, 2. And then the next corresponding pair would be 8 and 6. And then 12 and 10, and so on and so forth. Okay, so we want to read each of these descriptions. A says each pattern in term A is 4 times the value of the corresponding term in pattern B. So if I look at A, is it bigger than B? Yes, all the A terms are bigger than the corresponding B terms, but they're not 4 times bigger. Okay, in other words, if we took 2 times 4, that's 8. 6 times 4 is 24, and so that wouldn't work. For B, each term in pattern A is 2 more than the value of the corresponding term in pattern B. So we're looking for addition. Is 4 2 more than 2? Yes. Is 8 2 more than 6? Yes. Is 12 2 more than 10? And we just see that each of those works. So B is the correct description. So there you have it. Remember, 5th graders, there's often more than one way of solving these or approaching these problems, and I encourage you to solve them in as many ways as you can, as long as you're using sound reasoning mathematics.